Assalamualaikum to our panel, Encik Hakimi and Haji Salman. We are from Group KA41. We would like to present about visual inspection on tall building using Unmanned Aerial Vehicle, which is also known as UAV. This is our group member. My name is Amira, Nadia, Binti, Rizal, and my group member is Nur Edreena, Nabihah, Binti, Azmi, and Nur Edreena, Binti, Mokhzamany. So I would like to start with introduction. A building is a man-made structure with a variety of shapes and functions. Building is not something that is easy to build, and it requires high cost to build it. Generally, building categorized as tall building are those with roughly 7 stories of structure. The definition of maintenance varies according to the person who discuss about it. Maintenance is defined as the work required to restore and maintain each part of the building to an acceptable standard. Unmanned aerial vehicle, also known as drone or UAVs, that have been developed for military purpose, but in recent years, UAVs have been used in the private sector. So the objective of our case study is to analyze the type of damage and defect using the metric condition survey protocol (CSP) or application method that known as CSP1 metric. And the second is to identify the level of defect using CSP1 metric. So the scope of investigation is at building of the Faculty of Electrical and Electronic Engineering at UTHM Farid Raja. This study was conducted only on external structure of the building and did not involve any part of the structure within the building. So I will continue with literature review. A building that height of 75 feet and 491 feet is considered to be a tall building. An average floor is 13 feet, which is 4 meter wide. So if a building is 79 feet, that is 24 meter high, ideally it has 6 floors. So it can be considered as a tall building. Usually, visual inspection methods have been improved by using UAV. This UAV aircraft technology is considered as an important tool for controlling the scale of work and cost. Among the most common type of defect in the building are paint defect, crack, and moisture. So the assessment of the building condition, there are two types of building condition, but we choose to use CSP1 metric. This method has its own scoring system to make it easier for the examiner to carefully evaluate the condition of the building. In this metric, obviously, there are 3 colors, which is yellow, green, and red. For green code, that refers to defect that has score from 1 to 4, is a defect that needs planned maintenance. While for the yellow code, that refers to the defect that has score from 5 to 12, is a defect that needs a condition control. So lastly, for the red color, that refers to the defect that has score from 13 to 20, that need a full attention about the defect. Unmanned aerial vehicles are controlled either autonomously or by remote control by pilot from the ground and can carry various imaging technologies including video and infrared sensor. So in our case study, we use DJI Phantom 4 Pro. That's all from me. So I would like to pass to Auni Nabihah to continue with methodology.
So, hi, Assalamualaikum. My name is Nur Edreena and I will explain the methodology of our group project, which is visual inspection on tall building using Unmanned Aerial Vehicle UAV. So the study was conducted through several conservative phases. The following flowchart explain the step involved. So first step is collecting data, which we take pictures by using UAV. So the number two, step two is image analysis, which we identify the location and the type of the defects based on the image that we have taken. So we use Adobe Photoshop to edit the image. So step 3 is level of defect assessment. So after the process of image editing, we will use CSP1 metric to level the defects based on the defects diagram. So first step is collecting data. So collecting data is the process of capturing image of exterior structure using UAV aircraft. So capturing image by using vertical takeoff landing, which is VTOL method. So the figure show the example of front view of our study area, which is in FKE building. So the arrow that's shown in the figure is where the aircraft take off, and this is the lane where we start from the left side of the building and finish it to the right side of the building. So distance between UAV and the building is 2 meters, where if it is too near the building and the UAV, it will crash the building, and the study will be fail. And take picture every 5 seconds. So on the controller, which is the UAV, we already set the picture will be taken every 5 seconds. So then the defect will be clear, and the defect can be better quality, and we can take them to get the process of image editing, so the level of defect can be found out. So the total of image taken was 744 image, including all sides of the building, including the top of the building. And number 2, which is step 2, is data analysis. So through 2 stage, which is first, determine the position and time of damage. Second, assess the level of defect to the building using the CSP1 metric method. So for determining the position and type of damage, all the image zoom in and cropped it. It is in the image editing process. So from there, after the image zoom in and cropped it, so we can identify the location by using concept of grid. So concept of grid is the easiest way to find out the location of the image after the editing process happen. So number 2 is assess the level of defect. So to obtain the score value, the condition value should be multiplied by the priority value to obtain the score in determining the level of defect, whether it's a good, medium or severe, which is bad. So this is example of process of editing image to get a clearer defect. So from the first figure, which is gambar kerosakan sebelum diedit, this is the original picture from the UAV, and then after that we will crop it and zoom in the defect to get a clear and better visual. So the image, so the defect can be found out. And then the third one is the image after we use the Photoshop to edit to get a clear visual. So the other samples is cat berkapur, which is calcareous paint. So the first figure is the original figure that we take by UAV. And then the second one is the zoom pictures that already we zoomed to get the clear defects. And the third one is the editing process was happened, so this is the result. So then we can get a clear defect rather than the pictures that already we zoom in and cropped it. So this is a concept grid on back side of FKE building of our study area. So we use the numbering and also the alphabet to get easy way to get the easiest way to read. So then we don't have to be like cari or count. So then using this grid we can just find the defect image easily. So access the level of defect. So based on we use table 1 and table 2 in assess the level of defeats, which is table 1 is condition assessment protocol 1. We get the skill value from the condition based on the defeat, and the description are based on scale value, which is good, fair, poor, very poor, and dilapidated. And table 2 is priority assessment. The priority assessment, the scale value we got from the priority based on the pictures that already we edit using the Adobe Photoshop. And then the scale value, normal, routine, urgent, emergency will describe the descriptions. And this is the example of our CSP1 metric after the editing process, which is these pictures are from level 1, and the location is A1 Hadapan, which is the front side of the building, and the element is walls, dinding. And we use when we use CSP1 metric, the condition is in 2 and the priority is 1, then the metric is 3. So the color code that we found out is green, which is good, and the disability description is calcareous pain, which is cat berkapur. Cause of the disability is the chosen paint are not so quality and very poor. So for the proposal, we have to do plan maintenance, so then the defect can be controlled. So thank you.
Okay, now I will explain about chapter 4, image analysis, which is after the image of the defect had been through the editing process, which is determining the types of defect and the location. Image will be analyzed, which is in this chapter, based on the result that overall from all defects from all sides of the entire FKEE building. So based on this table, this is a table for overall analysis of the FKEE building damage defects levels based on the CSP1 metric that had been determined on chapter 3. So here we'll be determining the level of overall analysis of FKEE building. So the first step is summarize total the matrix analysis, which is 175, and then the summarize the total of the defects or damage, which is 38. Sorry, the total matrix is 172 and the total damage is 38. And for total score, the total of matrix divided by total of damage, so 172 divided by 38, we got 4.5, which is in refer to CSP1 matrix table in chapter 2. For 4.5 score, it is categorized in green color, which is in a good condition. So for the analyze, the total score is 4.1. So the score well all fine, and green color code specify that the defects of the external structure of the building FKEE are in good condition and enters periodic inspection only. So, okay, the last one is chapter 5, which is conclusion. For this study, we have achieved the objective, which is to identify the location, types and level of defects of external structure of FKEE buildings. The next one is using CSP1 matrix for analyze the levels of damage for FKEE building. And the last one is the usage of UAV is also help to be an alternative to carry out building inspection, especially on tall buildings, so can improve the quality and the time of work, also reduce the risk of hazard during inspection work. The last one is references. These are some references that we use for our case study. So I think that all from us. KA41 project title Inspection of Toy Building Using Unmanned Aerial Vehicle UAV. Thank you.